Moving on to trees. A tree is a graph that's connected and has no circuits, so it's circuit free. So it looks something like that, or it could something like that, or it could be like what you think of when you think of a family tree, right? So no circuits in family trees, and they can be really weird looking, right? So we could have something like this and here, and then this flying out here. So we can have all kinds of weird fun things. So as long as it's connected and it's circuit free. So that's a big basic definition of a tree. So what's a forest? A forest is a group of trees. There you go. That's a forest. 2 trees minimum, right? A trivial tree, there it is. That's it. It's kind of silly. Any tree that has at least 2 vertices, any tree with at least 2 vertices has 1 vertex of degree 1. So if I have 2 vertices and I have a tree with at least 2 vertices, has at least 1 vertex of degree 1. Okay, well this is degree 1 and this is degree 1. Okay, so let's make it a little more. So something like this, right? Has at least 1 vertice of degree 1. So I can see several, right? Okay, so now we're going to go into more, let me draw it over here. So get the little big tree going here. Okay, so these 3 things right here, let me put them in red. Red, red, red. Those are called the terminal vertex or the leaf. Okay, so let me use a different color, green. The internal vertices are the ones that are inside. So this one here, because it's the starting point, and this one here is on the inside. So those are called the internal vertices. Okay, so that's that. So any positive integer n, any tree with n vertices has n minus 1 edges. Oh, big one. Big important one. So if I have 2 vertices, I have 1 edge. If I have 1, 2, 3, 4, 5 vertices, I have 1, 2, 3, 4 edges. Ah, makes sense, right? Okay, so you can see it. So let's see. For any positive integer n, if G is a connected graph with n vertices and then n minus 1 edges, then conclude G is a tree. Okay, so let me just do one of these for you. So this first example here, make a graph with 5 vertices and 4 edges. Actually, you could do that. So make a, and make a connected graph with 5 vertices and 4 edges. There's a difference here. So if I have 5 vertices, 1, 2, 3, 4, 5, right? 1, 2, 3, 4 edges, 1, 2, 3, 4, 5 vertices. That's a graph, right? It's not connected. Didn't say it had to be connected. Make a connected graph with 5 vertices and 4 edges. There we go. 1, 2, 3, 4, 5 vertices, and then 1, 2, 3, 4 edges, right? Okay, so a connected graph with 5 vertices and 4 edges. Notice it has to be a tree. Yes, okay. So a rooted tree is one where the one vertex is distinguished, right? Like this is called the root. This right here, the starting point of it, it's distinguished from all the rest, where the others are coming out from it. So the level of a rooted tree is the number of edges starting from the root and moving down. So let me kind of give you a picture here. So if I have this root, and again, thinking family tree, and then this, and then this, and this, and let's do like this. Okay, so this is what I call level 0. This here I would call level 1, and this row here I would call level 2, level 3, and level 4.